Hello. In this video, we're going to look at techniques for finding derivatives. First, we're going to look at some notations. So the derivative of y equals f of x may be written in, of y equals f of x may be written in any of the following ways. So you've already seen this one before. You've seen f prime of x. That just means the derivative of f with respect to x. Now, the derivative is just a slope, and m equals y2 minus y1 over x2 minus x1. And here's the thing. There's another mathematical notation called a delta, where it just means change in. So this just means the change in y divided by the change in x. But as the delta goes to 0 and the delta goes to 0, what we do is we change those from deltas into just d's. So we change that into dy over dx. Now this is dy dx. That's really all it is. So that's a second way of doing that. So f prime of x is the same thing as dy over dx, meaning the derivative of y with respect to x. Now here's the thing. This y can kind of go out front, and that puts the y in parentheses, and y is just f of x, so we replace the y with f of x, and that gives us d by dx of f of x. So that's a third way. Now, a fourth way of looking at this is just kind of weird. The capital D just means derivative, and the subscript here is just with respect to what variable, and this is telling us what function to do that to. So d sub x of f of x. So there you go. Those are just different ways of writing down the derivative. Now, here are some rules for finding the derivative. First of all, we've got the constant rule. Basically, the derivative of a constant is 0. You can look in your text for more reasoning as to why that is. One of the most important rules in here is the power rule. And what it says is, if f of x equals x to the 9th power for any real number n, then f prime of x is equal to n times x minus 1. Sorry, n times x to the n minus 1. And so basically what's happening is the n goes down in front, and the exponent goes down by 1. And that's pretty much it for the power rule. Now, I'm not going to prove any of these rules. If you want to see proofs of it, I will be happy to show that to you in class. But for now, generally speaking, these are just the rules that we're going to use. Constant times a function. So basically, if you've got a constant times some other function, like this, then the derivative of that is going to be that constant times the derivative of that function. And then sum or difference rule. If you have a sum or difference of two functions, then it's just the sum or difference of the derivative. That's pretty much it. Now, this one isn't really that big of a deal. That just means that the n for up here can go out in front of any constant. In other words, this exponent can multiply by any constant here to give you the derivative. And of course, take the exponent down by 1. Alrighty. And believe it or not, that really is it for now. That's actually enough to do a whole lot in this class. So I'm going to go ahead and end the video here, and we will see how that works. I'll see you in the next video. Have fun.